Hello, my IITians and future NEET aspirants. Welcome you all to this beautiful channel. So I know you started your IIT and NEET preparation. So let's get started this preparation with beautiful feeling of physics. You know, physics is very hard, some people think, but if you enjoy the feel of physics, it's very easy. Similarly, these chapters, vectors is there now. This is basically motion in a plane topic chapter, but we study this first because if you master in this chapter now, then 50% of hardness in physics is complete. I can bet it. If you good in this chapter, then 100% you will good in all the chapters. This vectors is basically mechanic topic, but it will come in electronics also, all over physics. Okay, na? So let's get started. Myself Tofik, and I teach you physics for IIT, NEET and JEE also. Okay, na? And if some questions we are doing for IIT, I will tell you to skip NEET students. Don't see that student. Okay, na? If you feel very hard, you can. If you feel very lengthy videos, you can keep at speed 2x or 1.5x. Your wish. Now let's get started. What do you mean by vectors? Vectors. Any idea? Any idea? Any idea? No idea. I will tell you. See, when you go to a market, if you are buying some tomato, onions, what you will say them? Give me 5 kgs of tomato. 5 kgs of tomato. Give me 5 kgs of potato. Or else you are seeing time. What you will say? It's 5 o'clock. It's 2 o'clock. Array temperature, cold temperature, 30-degree temperature, 37-degree temperature, 27-degree temperature. Now you won't use now. Give me 5 kgs tomatoes in the direction of north. No. It's a time 5 o'clock in the direction of south. Do you use? No one use. Temperature is 40 degree in the direction of desert area. No, no. No. Similarly, but when you are saying velocity, for suppose velocity, let's say you are traveling from one point to other point, you will say I traveled from my home to school at 5 kilometers per second. Right? Why you use that? Why? What the difference between this and this? That is, we are learning in this chapter. So basically vectors means, before that, physical quantities. Now in physics, you know what the physical quantities? Physical quantities is in your first chapter, units and measurement. Don't worry, you will study that chapter in the last, because it must need all the knowledge. Okay, now so physical quantities, in physics there are few physical quantities like mass, temperature, dependency, velocity, torque, everything comes under physical quantities. Okay, now in these physical quantities we can classify physical quantities based on two types. One based on direction, one based on derivative. Based on derivative, this word is very important. Based on derivative, which means deriving. In this, one fundamental quantities. Fundamental means which is nature, which is from the initial of universe, before you, before your dad, before you were anyone. These are seven physical quantities which is derivative. We will study in this first chapter, don't worry. And this is derived quantities which derived by using these physical quantities, 7 physical quantities, that is called as derived. And we don't need this in vectors. Now basically comes to the main part, based on direction. Now we can classify vectors on 3 types. Scalar, we can classify physical quantities on 3 types: scalars, vectors and tensors. Now what do we know? The scalars, this vector, this tensors. Just now I said when you go for a shop, you will ask for 5 kgs, number 5 kgs, 5 seconds, 30 degrees Celsius. These are all magnitudes. They don't have direction. So you can say scalar is a physical quantities which has only magnitude, which means only number. Scalars is a physical quantities which has physical quantities which has only magnitude, only magnitude, like 5 kg potato, 5 kg, 2 hours. Example for this is, examples are, you can give many examples as ever you want. First you can say distance. Yes, distance. Sir, distance is a scalar. How, sir? From that point to this point, distance is covered now. Then how scalar? I will tell you, don't hurry. Distance, temperature, you can say time, you can say mass, you can say density, volume, you can say density, many more, only which has number, no extra, only which has number. For example, 5 meter distance from A to B. At 27 degrees Celsius of today. Time, it is now 11 a.m. Mass, my weight or anything mass. Potato we got 7 kg, 5 kg. Yeah, okay, adjust 5 kgs. And one more thing, the main important is this scalars is there now. We add these scalars based on just algebraic addition. Simple algebraic addition. What do you mean the mathematical addition? Algebraic. When you have 2 kgs potato, just imagine I have 2 kgs of potato. I am adding 1 kg extra to this pocket. Then how much it will happen? 3 kgs. Simple algebraic. Now, if I have 5 kgs, I am removing 2 kgs. Then what it will be? 3 kgs. No? Which means you can say this vectors is follow algebraic addition, algebraic sum or algebraic sum or minus. Okay, now that's it about scalars. Nothing more in scalars. But basically scalars we don't need. In this chapter because this needed just for knowledge. This is very important. This vectors is like your girlfriend. Yes, your girlfriend or boyfriend. If you understand, if you love this, then all your hardness is completed. Finish. Like if you understand your girlfriend or boyfriend, then your life will be very happy, life long lasting. If you don't understand, break up. Similarly, if you understand these vectors, your physics is going to be super. If you don't understand, break up. So what do you mean by these vectors? These are the physical quantities. These are also physical quantities. Let's write first definition. Physical quantities which has magnitude plus direction. Which has magnitude plus direction. That's it. No, there is one more thing. It follows and plus obeys addition of vectors, addition laws of vectors. And this is very important, obeys addition laws of vectors. This one and this one is very important. Vectors is a quantities which has direction, which has magnitude, and which obeys triangle law of addition. So simple thing. Wow, for example, let us give some examples. What you can take? Examples. You can say displacement, velocity, acceleration, etc. Now, sir, distance is a scalar, displacement is a vector. How? What is going on? Nothing going on or half. Don't worry, I will tell you in clear explain. Now basically this is vectors, scalars. Now there is one more quantity which is not in your syllabus, which is not in your 11th and 12th syllabus, but we must know what does it mean. Okay, now that quantity is tensor. Now what does this mean, tensor? This means tensor. This is like intermediate. It has magnitude, it has direction. Is it vector? No. It has magnitude, it has direction, but it don't have this property. Tensor, you can say tensor which has magnitude, direction, but don't obey law of addition, law of vectors. Don't obey addition law of vectors. Sir, what is addition law of vectors? There are two laws, very simple, two laws. One is like triangle law of addition vector, and one more is a parallelogram of law of addition. both parallelogram of law of addition. Okay, now parallelogram of addition and triangle law of addition. This won't agree. Sir, give me an example for this. Yes, I will give you an example. For suppose you can take electric current. Sir, how current has direction from this point to this point it is moving, it has direction but how it come? I will tell you, don't worry. For suppose here imagine 5 ampere of current, here 5 ampere of current. Now what is the output? Very simple, 10 ampere of current. Now is it complicated mathematics or algebraic mathematics? So algebraic mathematics or it's vector mathematics? It's just normal addition. This one, which means this also this one. Yes, for you this is this one, but basically this is this one. Sir, what is this sir? Arey baba, what I am telling is simple. See, when they ask question, electric current is which quantity, scalar or vector, you must pick scalar. If they ask electric quantity is which quantity, electric current is which quantity, scalar, vector or tensor, at that time you will take tensor. If they have mentioned tensor, then only you will take current as tensor. If not, you will take current as scalar. Okay, clear? Okay, now note down quick. Okay, come, let's move on. Basically that is a basic building for your vectors. Now we will see the difference between scalar and vector. Sir, we are waiting for this. Yes, you are waiting for this. I am also waiting for this. Let's do this. Yes, let's do this. Now basically imagine you are a boy. This is your school. You are standing here in school. Okay, school, and this is your home somewhere. This is your home. Okay, home. Okay, home. Super. Now after leaving the school, your road is like this. Now tell me, this full road from this point to this point, it is like somewhat 10 kilometers. Okay, 10 kilometers. Now tell me, in this, how can you say distance and displacement? Sir, very simple, sir. All this distance is distance and the shortest distance from this point to this point is displacement. Yes, of course, right. Now how can you vary this in vectors and scalars, sir? See, vectors means which has particular direction. Now I will show you distance. Why distance is not vectors? Oh, okay, write us right here for brave person. Why distance is not vectors? Why? Very simple. See, if you start here, I am indicating direction. If you start here, your direction like this, your direction like this, like this. Now turning, your direction like this, and here your direction like this, and here your direction like this, and here your direction like this, here your direction like this, and again turning, your direction like this, turning direction. This is direction. How many directions? Arey baba, sir, stop, sir, I am unable to see, sir. Direction. Now here it is like this direction. Now finally this direction. Basically this is your distance. Now tell me you have 10 kilometers magnitude. Which direction you will take? This direction, which direction you will take? Yeah, Yes, sir. We didn't ever observe this. I am here not to make you observe. Think. Very hard, very hard. But what if you remove this all? What if you remove this all and just take a displacement? Take a displacement. How? From initial point. You are going to final only now. So from initial point to final point. Now can you tell a particular direction? Yes, sir. My eyes are open now. I can tell a particular direction now. How da? How? Okay. Before that, I will make sure that you will learn one small thing. Direction south, north, east, west. Okay. How? See. This is very important. All make confusion. No, whatever we have just this ones, right? North, south, east, west. Just remember news. NEWS, news. Okay, now here, north, east, west, south. Okay, now just remember news. Substitute here north, east, west, south. So okay, simple. Now see, basically when you go from here to here, you can say particular direction. For suppose if I take here directions, if I take here full directions, axis, you can tell you travel east to south. You traveled east to south. Very simple. But if you take here, first you travel at the northeast, again you turn at this side. Complicate things. In physics we don't want complicated things, we just want simple things. Okay, displacement has particular direction. Because we are going from one point to other point only, we just need that one. Why we need this? All idiots. Like idiots, these are idiots, not you. You are the very good students, these are idiots. Okay, now basically that's it. If you want to take it, or else leave it. It's up to you. And one more thing, in vectors in your book or in any competitive exam, they will represent by bold letters, just like this is not board, sir. This is board. Like this, whatever the A to Z, anything A to Z, and this magnitude they will represent by small. Okay, now after this let us see the representation of vectors. Now what does this vector, how we represent this vector? This north, south, east, west, be clear in that. Okay, now vector, you know, vector is very simple. It's just like us representation of vectors. Vector is just like men. It's just simple men. See, vector is just an arrow. It's just an arrow indicating a direction. Okay. This we call it as head, and this we call it as tail, and overall this is there now. This we call as magnitude. And for suppose this is vector, we will represent vector as P in that direction. For suppose this is going from A to B, let's say it is going from A to B, you will say vector from A to B. Simple thing. It has a head, it has a magnitude, it has direction. Tail. Okay, simple thing. Now I will tell you one small thing. See, when two vectors are in same direction, when two vectors are in same direction, when two vectors are in same direction, you will add up. You will add up. It will add up and give a new direction. For suppose this has 5, this has 6, then the resultant will be 5 plus 6, 11. Sir, you said it is follow triangle, Lana, sir, something. Arey Baba, it will follow when it has some angle, but here no angle, so directly. Now after this I will tell you how this happens. This also follow triangle, but how happens we will discuss. There are I something. See, basics are coming. When basics are coming, complicated will be easy. So just chill. Now opposite direction. Opposite direction very simple. Subtract. Opposite direction. For suppose 5, 6. Then wherever the higher, it will go in higher way. Resultant it will be like this. Resultant. Simple. Yes, simple. Now basically this is representation of vector. It has a tail, it has a head, and whatever the body full, it is magnitude. For example, let us take, okay, no, let us take first direction. Now vector is in this direction, 5 meter per second. So you can say this full length is there now, it is 5. If length is less, see, if length it is 1 meter per second, then it will be like this, small. If it is 5 meter per second, then it will be huge, high. Okay now? Okay. Now let us come to this one. Now you can say direction of vector is 5 meter per second northeast in east. 5 meter per second in east. Okay now? Okay. Now take down. We'll just continue this. Okay now? Okay. Now let us discuss the types of vector. This is basically very important. Because once you know this good, then everything will be good. Types of vectors. Now there are basically many types of vector. We will discuss one by one. First of all, let us get started by polar vector. First one, polar vector. Now basically polar vector is very simple. Any vector which has a starting point. For suppose a car is moving, it is at rest, it's started now. It has a starting point. Any vector which has starting point. Any vector which has a starting point. Okay. For suppose, let us take this one car. It is at rest. Alien car is just started. It has a starting point. This kind of vector we call as polar vector. Okay now? Very easy thing. Now second one. It is like axial vector. Axial vectors. Now what does this mean by axial? A rotation of any body with respect to its axis, with respect to its center of axis. Rotation of any body. I will tell you, don't worry. I will explain you, don't worry. Rotation of any body with respect to its center of axis. This is called axial vectors. Now sir, what is this? Adi, what is this? Don't worry. It's just simple thing, In your home, fan is there? Fan. It's like this, fan. Fan. It is rotating. At a one center. One center. It is only one center na. It is only one center. It is only one center. The fan is rotating like this. Fan is rotating like this. This is axial rotation. Rotation. And this is there now. With the respect of this axis, it is rotating. This we call as axial vector. This we call as axial vectors. Axial vector, and this is axial rotation. This is your axial rotation. This is your axial vector. Now in this they will come angular momentum, angular velocity. We will discuss further classes. When we need we will discuss. Okay, now after this one more example. I think in your home, in your grandma home, you have seen this. See, there is one rock, and in that one, now I think everyone got it. They will rotate now, to grind the weeds and all that kind. So in this also, this is your axial vector. On the basis of one axis it is rotating. It is your axial vectors, and this is your axial rotation. Sir, why we need in this physics? Very simple. In your everyday you have seen center rotation. When you tie a rock and rotate, it will rotating at one center point. That all daily life examples. So we are studying this on the basis of daily life. Okay, now if you want, take down. Okay, now I am rubbing this. Now third one is also very easy. Let's say equal vectors. It's simple. The name itself telling the vector which has equal magnitude and same direction and equal magnitude. Same direction and same magnitude, equal magnitude and equal magnitude. For suppose example, let me take two vectors. See, two vectors 5 meter per second, for example 5 meter per second. Both are in same direction and both have magnitude same, right? Now if I take this also, for suppose let's say 4 meter per second, same direction, no matter the any direction, but same direction with same magnitude. Okay, now equal vectors. Now similarly there is one more thing, negative vectors. Just simple, equal magnitude, opposite direction, opposite of this, or what do you say, opposite direction and equal magnitude, simple things need simple solution. For example is very simple. 5 meter per second. Now is the same direction? No, it is opposite direction. This opposite direction represented by I, J, K. I will tell you. Now this is your negative. After this negative there are collinear vectors. There are collinear vectors. Now what does this mean by collinear vectors? These are very simple. Two vectors in the same direction parallel to each other. No matter of this magnitude and all, they must be in same direction parallel to each other. Same direction or parallel to each other. Okay, now two vectors which are same direction or parallel to each other. Simple thing, same direction or parallel to each other. For example, see, if it is a block, here it is a 5 meter per second, let's say 5 Newton of force acting, and in the same here also 5 meter Newton acting, then this both will be same direction, or else it may be down also. Not only this, see, not only in a same particular line, it may be this and here, but both are parallel to each other now. It is collinear vectors. But any vector like this perpendicular, it is not collinear. This is not collinear. Only this one is collinear. Collinear. Okay. Co-initial. One more point. Co-initial. The name itself telling it has same initial point. Which has same initial point. Co-initial. This is very important. Basically, this is only the important. Vectors, many vectors or same vectors or many vectors. Now vectors, I will take vectors. Vectors having same initial point. Now if you want, take down, we will discuss this co-initial vector little more. Vector having same initial point. Okay man, okay, cool. Screenshot or whatever, pause the video, write it, because while listening, writing is very good. No, listen the class first carefully, after that try to write. Very good. Now co-initial vectors is like this. Let us take one point, one vector, two vectors, three vectors, four vectors, n number of vectors from only one direction. You can say only three vectors also. This is basically co-initial vectors. And there is one much important, very much important, coplanar vectors. Two vectors in the same plane, vectors in the same plane are called coplanars vector. Array sir, very simple sir, why you are teaching this sir? Very simple sir. Nothing is simple, if you learn it is simple. Vectors more than, I am taking vectors, not vector. Vectors are in same plane are called coplanar vectors. Now what is this coplanar vector? Sir, we didn't understood. Okay, I will give you one small demonstration. See, this is one plane. I am not asking about 3D. I am just telling 2D. This is one plane. This has some y axis, x axis, y axis, x axis, y axis, x axis. If it is 3D, y x plus z, y x plus z. Now we are talking about only plane means x and y. Now if I take these two vectors and keep here x axis. Okay, let us write for you. This is your x, this is your y, this is your x. I am taking two vectors, keeping in this plane. Two vectors or maybe three vectors, four vectors, n number of vectors. Not only this plane. Let us come from z plane, z and x plane. Z, this is going this direction. Z, this is going this direction. Now if I keep here two vectors, it is co-parallel to x and y, x and z. Now it is co-parallel to x and y. Simple case. Now in this, whichever the direction, we are not talking, but it must be in one plane. Okay, now understood? Clear cut? Okay. Now there is one small point which is much necessity. Minimum 2 two vectors must be there for coplanar vectors. Now see, just simple, if you remove all this, there is only one vector. Is this coplanar? No, it is not coplanar. If you add one more here, then it is coplanar. Yes, it is coplanar. Or you can add in same other direction. Coplanar. Yes, it is coplanar. Yes, it is coplanar. Now if you have n number, okay, but what is the minimum amount of you need? Minimum 2 must be there. This is very important point, very important point. Note it down, baby. Sorry. After this, there is one dialogue in Hindi which is like Abbu are, like that. Now this is all our babies, small babies. Now grandfather is coming there. Grandfather. What is this grandfather? Who is this grandfather? Grandfather of vectors. Unit. Vector. Grandfather. Respect. Hello grandfather. How are you? Did you had your lunch? Respect to grandfather. Now why it is very important? I'll tell you. Basically, unit vector means a vector which has magnitude 1. Sir, it has 1 magnitude. Why we are fearing with this? No. We must give respect. The vector having magnitude 1 and direction of course is present, and this we use to only for represent direction. For suppose, always remember, unit vector is represented by vector cap. Okay, vector cap. Unit vector is equals to that vector divided by magnitude of vector. Magnitude of vectors. This is basically unit vector, and this is the most important thing in your vectors. Is very much important. Very much important. Very much important. Unit vector, the vector which has a magnitude unit or 1 unit. Unit means you can know unit means 1. Maybe it is 1 second, whatever. 1 must be unit. Okay, now unit vector. Okay, father, we'll give some respect and we'll run more thing about you. Okay, come on, I will teach you more thing about him. Okay, now more thing about him. Now I will take you to a world of vector, unit vector. Just simple. Let me take a plane. Okay, plane. This is x, this is y, this is minus x, this is minus y. 4 coordinates x, y, z. Sorry, x, y, minus or minus z. Okay. Arey Baba, not okay. I am not okay with this. I will take here x because I want x here. I want my x to be here. No next, only x. Now in this direction, unit vector means very simple. This will be 1, this will be 1. Unit vector, unit will become only 1. So unit vector of this direction, unit vector of x is, unit vector of x direction is, we call it as I cap. So you can come here, you can write it as divided by like this. Unit vector of x positive. Here it is unit vector of x negative, and here it is j. Okay, now y is equals to j, minus y is equals to minus j. So simple thing. So simple thing. Now in this, if I take a vector, carefully listen here, switch your nothing. Now if I take here vector, one vector, for suppose no vector, let me take here one point, let me take here one point, okay, this point is made up of x and y, agreed? Yes, this point is made up of x and y. Let us take point P, okay, now from point P from now vector PO is equals to sum of this. Sir, this I am talking about this one. I am talking about this one. Okay, simple. This vector has some. So in maths, how you can write? You will write like this now. You will write like this. Same that we are substituted here. IJ, unit vector. Whatever the values multiplied by one only na. Unit vector. Now, if you want to write this full vector, unit vector, this single unit vector of x and y. If you are combining, want to write this unit vector, very simple, very simple. Unit vector cap is equals to, Arey Baba. That's it. Okay, fine. Okay, take it. Now, for suppose, in this direction, if you take Q, at that time, carefully, here see, y is positive, x is negative, minus x, comma, y, at that time, OQ is equals to, x is negative, yes, which means minus I plus y is positive. So you can write minus x ka I direction minus plus y ka j. We are building basics. These are all basic. If you are feeling very bored, then if you know all the basics, you can skip up to 10 minutes. But I don't recommend. Okay. Now same thing when you go for this one. When you come for this one, sir, we know this one. We will write this one. Yes, we will write this one. Let's say OQR. Okay. R. Sir, OR is equals to, I am feeling like this, sir, plus this I am feeling. Yes, you are right. Of course you are right. Now one more thing here. Write it. Try it. Okay. Very simple, right? Very simple. Now let us say simple, same thing in 3 dimension. See, you are waiting for addition. I know. But building basics is very important. Without basics, you feel very bored. You can't do any problem. Okay. So let us see some 3 dimension. Same thing in 3 dimension. 3 dimension, what happens? 3D, 1D, 2D, and this one 3D. Yes. X minus X, Y minus Y, Z minus Z. Okay, sir. Here it is. Okay. 2D over. Now 3D. Now if I take a vector here, somewhere here, vector A, it is combination of x comma y comma z, right? Yes, of course, right? Now if I am taking here all positive, if I take here two positive, one negative, if I take here all are negative, if I take in this 2 negative, 3 positive. Now for this, how can you write? Very simple. Same thing. See, OA vector is equals to x of I plus y of j plus z of k. That's all. Now this is vector. Oh, okay. Yeah, I got one more thing. I got one more thing. See boys and girls and others, whatever. This is vector. This is vector. Sir, what is its magnitude? Sir, it is vector, but what is its magnitude? How? See, 5 kilometer in north direction. 5 is their magnitude. It is full direction. I is here, J is there. Now what is its magnitude, sir? Magnitude. Very simple. For this kind, OP magnitude is equals to square root of. You are brave. You are very talented, Ra. You are very talented than me. And here also, OA is equals to square root of. Sir, this is easy, sir. Yes, easy. If you know, easy. X square plus y square plus z square. But in some books they are taken ax, ay, az. In some books they are taken like ax ka square, ay ka square, and here also both are same only. Not see, we must understand the concepts. Everything we can do. We are not studying here for CBSE. We are studying here for competitive. Yeah, basically this is. And why this comes? Now, is there any something here? Is there any something here? It is there. I will tell you, don't worry. I will tell you. I am here to tell you only now. Now, if you write this unit vector, if you write this both unit vector, how can I write unit vector of this? Unit vector of this OP ka cap. First unit vector we know. First direction unit vector. First direction divided by magnitude of unit vector. Magnitude unit vector. Similarly for here also. Similarly, sir, why again writing, sir? Arey, we have to write, Ra. We have to write. See, this if you don't know, then it's going to be very hard. It's going to be very hard. I am teaching from root. So that your root must be very strong. See, I don't know who is seeing up to here, but if someone seeing up to here, bro, congratulations, you are going to crack. Okay. Now basically this is unit vectors. Unit vector in this directions. So now position vector, position velocity and acceleration vector. Now how this position varies, acceleration varies. Now one second. Okay, so how this position, velocity always. In last slide you just saw 1 point xy, but here position means what? Position changing, 2 points must be there. Similarly here I am taking 2 points P1, P2. Okay, now suppose imagine we are traveling from P1 to P2. We are traveling from P1 to P2. Okay, now we are traveling from P1 to P2. At this time, how can you represent position, displacement, position or displacement? Very simple, sir. First we'll draw one like this, one like this. It's just too simple. It's just to show. Okay, now this let's say R1 and this say vector R2. Now this P1 has coordinate both of this. For suppose let's say x1, y1, and this one has x2 comma y2. And sir, we know for writing position, for writing position, we know final position minus of initial position. This we know. Yes sir, we are learning from many years. This we know. Now P2, what is this P2 value? It's very simple. x2 I cap, yes, x axis, sorry, x vector with I direction plus y vector with j direction, final minus initial x vector with I direction plus y1 vector with j direction. Now if you substitute here, what will come? x2 minus x1 I I plus y2 minus y1 का j. So how can you write this as like this? Like this. Yes, we can write like this. Yes, we can write like this. Total position vector. This is basically your position vector. Now if you want to write same position vector velocity, same for velocity. Okay, let us write same for velocity, and through points P1 to P2. This is x-axis, this is y-axis. Okay, while writing for velocity, very simple. It's traveled this distance in this time. So how can you write? Sir, very simple, sir. Velocity we know. Velocity, what is it? Velocity is equals to distance divided by time. Now distance, we have this. Here we have some distance, which is plus, okay, divided by dou t. Now can I write this separately? X t plus y dou ka j. Yes sir, we got our final answer, sir. V of x plus vy of j. So simple. For magnitude, you know what to do. Just square root of, for magnitude very simple. Just square root of vx square plus vy square. And here also magnitude very simple. Just dou x square plus dou y square. Now similarly for acceleration also you can write. For acceleration also you can write. Acceleration is equals to v of x. Acceleration is equals to velocity by time. It is average velocity. When you're talking about instantaneous velocity, you will write like this. I will tell you. So now what will happen? Vx of I plus Vy of j divided by dou t. Now this becomes again same. Now it becomes acceleration. X y acceleration, total acceleration. Basically we are trying to say these vectors can be used in the form of acceleration, velocity and displacement. We are proving velocity is displacement, acceleration is a vector quantity. Clear guys? If you want to take, you can take it. If you want, then only, or else your wish. So now we are going to study a very important, because it is resolution of vectors. Every year we will take resolutions now. This year I won't eat junk food. This year I will become 6 packs. Similarly, resolution of vectors. Now what is this resolution of vectors? Don't worry, I am here to tell you only. I will tell you simple thing. Now basically if you have a vector, only vector, if you have only vector like this, for suppose let's say this vector a, now how can you say x component of this vector and y component of this vector? How? Okay, that is what we call as resolution of vectors. It is just simple components of vector. We are telling the components of vector. We are dividing the components of vector. You can say resolution of vector is nothing but component of vector. How this component comes? Let us see. Now basically this is vector. So can I write here x and y direction? Yes, I can write here. I can write here x. I can write here y. Now let's say it is making some angle theta with x. Angle theta with x. क्या बात है? क्या बात? Now this x component and this y component I want. It's just simple. See, here we have x and y now. Here I have x and y. Now I want this x component of this vector and y component of this vector. Very simple. This is like x component of vector or a x component of vector is equals to a x component of vector is equals to a cos theta, a y component of vector opposite to this side, a sin theta. Now, sir, do we need to memorize this? Memorize this. I don't think so. Yes, I don't think so. Because I will tell you now. I will tell you. Now, if you closely see, there is one property of vector. You can shift vector places. For suppose, see here carefully. This is one vector. Let's say any vector. Now, here is one more vector. Now, if you want to get angle between these two vectors, let's say A and B, angle between A and B, that time you can't take angle between head and tail. You will take angle only between tail and tail. Remember this. Angle only between tail and tail. Okay now at this time what to do? Very simple da. Can I shift this vector here? Yes, shifting is possible in vector. Okay, see, now if I shift this here tail to tail, it will attach like this vector, and here vector. This is A, this is B vector. Okay, let us like write neatly. Now can you tell angle very easily? Yes, very easy. This is basically very property. Now I will tell you similar to this few more properties. Properties of vector. Write it. Yeah, we will discuss this. We want this, that's why we are discussing this. Don't worry. Properties of vector. First of all, vector can shift one place to other place. Just now we saw vector can shift one place to other. If this is the case, one thing I can take this and keep it here. Other thing I can take this and keep it here. Didn't understood? Yes, I can take this and keep it here. At that time what happens? Okay, let's see, shifting this to this side, this to this side. Okay, A, B, or else I can shift this to this side. Same thing will happen now. Same thing. See, this vector, now shifting this to this side. Same thing, angle theta. This is B vector, this is A vector. Shifting can be possible in vectors. Now there is one more thing. Okay, this is okay, fine. This is one thing. Vectors can be shift. Okay, vector can be shift only parallel places. Sir, this is a vector. I will write it down. No, if it is a vector, if you want to shift anywhere, same way must be there, not rotating and all. Okay, first point, vector can be shift, vector can be shift. Okay, okay, super. Now second one, always we take shortest angle, smallest angle, always we take smallest angle, sir. Enada smallest angle, I will tell you. I am here now, why you will fear? This is one vector. Okay, now for suppose, let us say same example I will take. Okay, this is vector B, vector A, vector B. Now I said we want shortest angle. If you see here, this is huge. No, but when I write like this, this become very shortest angle. Now similarly I will show you big angle in this. Big angle. This is your two vectors, right? Vector A, vector B, this is theta. If it is A vector, then this side it will be minus A. Yes, minus A. Now this full length will be 180 minus theta. Which is short? Which you want to take? This is 180 minus theta, this is 80. Which you want to take? Shortest angle. Always remember, in vector we will take shortest angle. Now there is one more thing, negative vector. See, I will show this in this clearly. For suppose this is vector B and this is vector A. Okay, there is some angle theta. Now if I draw this negative,